Good morning, everyone, and welcome to Autodesk Virtual Academy, brought to you by KETIV Technologies. If it's your first time here, definitely welcome. AVA or Autodesk Virtual Academy, you'll hear me use those two terms intermittently, is our once-a-week learning resource all about Autodesk's product design and manufacturing collection, as well as Vault Professional. So if you have those tools, come back to learn every week, Thursday at 10 o'clock Pacific. I'm Nigel Ambayec, Customer Success Engineer here at KETIV Technologies. And today I'm actually hosting and presenting, so I'm really excited for today. We're going to be going over Inventor Shape Generator. And you might ask, what is Shape Generator, right? Inventor is a 3D parametric modeler. What do you mean about generating shapes? And what I mean is we're going to go over here into our next slide and take a look at that. But first, if you have any questions, please go ahead and ask them into the GoToWebinar chat panel at any time. And I'll make sure to answer them during the session or at the end if we have some time, which we should. So expect to be here. My presentation is somewhere between 30 and 35 minutes long, and Q&A right after that. So not too long today. Let's go ahead and get started. Here we go. What is Shape Generator, right? So at its very core, Shape Generator generates shapes. But what kind of shapes, you ask, and why do I use it to make shapes? Well, it's a new approach, right? If you think of it, it's an approach to design lightweight and structurally efficient parts. So a lot of time when you do design things, you might over-design them, or maybe you'll go through a lot of simulation phases to make sure that you're using the right amount of material in the right places. Maybe you want it to look aesthetically pleasing as well. And what you can do is you can use Shape Generator or, at its very core, generative design to come up with a shape per se that holds your design in the way that you want it to in regards to holding the loads and pressures, so on and so forth, as well as utilizing the least amount of material possible. And with the addition of generative design in the manufacturing workspace over the last couple of years, this has become a lot easier to manufacture, right? If you see maybe something like this bracket here on the right, if we cut away those holes that aren't meshed right there, it's pretty easy to manufacture, right? You just, you take your CNC machine and you cut those pockets. When you've looked at some generative design for maybe furniture or something, you get these crazy lattice structures. Maybe you've seen some of the Under Armour shoes. Those also use some generative design, and then they 3D print the soles. It's a lot easier to make those with additive manufacturing as opposed to subtractive, right, as we used in the past with our CAM machines, so on and so forth. So it's a simulation that's built directly into Inventor. You pop your original design in there, right? And that's maybe this full bracket, right? No holes. The holes just for the mounting, but it's a complete solid bracket. Once you put that into Shape Generator, essentially what it's going to do is it's going to create a shape for you that takes away as much material as it possibly can based on the criteria you put, and gives you a nice shape to use later. And lastly, I just want to emphasize this too. The use of this tool isn't necessarily to create your final design, right? You want to use this earlier in your design phase to get an idea of what areas you don't necessarily need material in, and get you, started building your final design. It helps a lot doing it this way as opposed to maybe guessing where these loads aren't going to be, and designing that way, because then, you might break some in physical prototyping or, jumping into InCAD or simulation later, and running, bend tests on this thing and having it break. So I want to emphasize that use it early in the design stage, because if you don't, it'll take you a lot longer. So let's go ahead and jump straight into it. I know it looks like there's a couple of questions coming in already. Just want to make sure. Oh, okay, cool. Only seeing the first page of the presentation. That is my bad. So let's go ahead and take a look at this. Apologies for that, everybody. So yeah, generating shapes, its approach to designing lightweight, structurally efficient parts. It's a simulation that's built directly into Inventor Professional. Or if you have the collection, right, you have Inventor Professional as well. It's in there, and then use it early in the design stage. So let's jump straight into Inventor. We're gonna try something different today. I'll leave the camera on the whole time so you guys can see me working in Inventor. So let's go ahead and take a look. Awesome. So I've got Inventor Professional 2019 open. For Shape Generator specifically, it is something that released in 2018. So in the version 2018, not year 2018. So if you're on 2017 or older, you might want to move forward if you want to start leveraging these tools. So I'm in 2019. So I already have some examples open. Let me go ahead and share those with you. So let's go ahead and take a look at we'll take a look at the finished part. So I took a bracket and I used Shape Generator to generate this shape. I made some manipulations to the actual part, and I'm left with this. And this happens to be about 40% as heavy as this. And this is the original part that I had created. It's pretty simple here. Simple link connecting two things, and there's a pin here in the middle, having this thing go back and forth in such a way, right? If I load one side, it's going to go down, create some stresses in the member. So what I'm going to go ahead and do is show you how to get to Shape Generator, right? Not to be confused with Frame Generator in any way. So what you're going to be doing is you're going to be going over to the Environments tab. And as you can see in the Environments tab, there's a couple of environments for Inventor, being stress analysis, right? You've got Inventor Studio, so on and so forth. If you have some other third-party add-ins, they'll probably fall into this place as well. So we're actually going to go into stress analysis, which is a little weird thinking about it because we're generating shapes. We're not necessarily doing a simulation, but actually at its very core, you're performing a simulation. So we're going to go ahead and jump into stress analysis. This is not Nastran in CAD. That's a completely different area in Inventor, right? This is the simulation that comes with Inventor Professional. So like everything else in Inventor and pretty much all of the Autodesk products, you work from left to right on the, I guess if you're looking on your screen, it's this way to that way. So left to right. And so we're going to start in the ribbon on the far left. We're going to create a brand new study. And you do the same thing for static stress analyses and modal analyses in Inventor as well. As you can see, once I have the new study up, I can go ahead and select Shape Generator. That's what I'm going to do. It's this third guy down here. Once I select Shape Generator, there really are no other criteria I need to fill out. Those are really for the other kinds of simulations that are available. That's static, stress, and modal analyses, respectively. So I'm going to go ahead and hit OK. And it's going to fire a brand new Shape Generator study. My old one's still here. We can ignore that for now. And like I said, we're going to work from left to right. So the next thing we're going to look at is material. And the material, like all of the other simulations in Inventor, whether it's Nastran or regular Inventor Professional simulation environment, it grabs the material that you've assigned in the modeling space itself. So in this case, I assigned steel to this. It's going to carry that information over. Say you open this file, it came from maybe a SolidWorks source or maybe a Pro-E source. A lot of those I properties do carry over, right? So for material, you'll say something along the lines of SWX and C or maybe aluminum 6061. It's going to carry over the information it got from SolidWorks, perhaps, depending on what version you're coming from, obviously. So just note it's going to carry over those properties. So I'm going to keep this as defined, and I'm going to have my safety factor based on the yield strength. I can have it based on the ultimate tensile strength. I really don't want that. If you've taken a materials class before, you understand that the curve goes like this, yield strength, and then ultimate tensile strength down that way. So let's go ahead and keep working. So I'm going to hit OK. It's going to assign it as steel. If you want to change it there, you can. You can play around with different kinds of material, right? Because different materials are going to have different kinds of densities. Getting rid of certain, obviously, they have different material properties. They're going to hold different stresses, so on and so forth. So it's going to actually change what your simulation is going to look like. So continuing that, we're going to add constraints, right? So this is much like a regular simulation, right? If you were to work in CAD or regular Inventor. So we're going to go ahead and add some constraints. So the idea is here is this center hole, right? We're going to pin this, right? So it has the ability to rotate. This top hole here in the top left, we're going to go ahead and fix that. So it's a fixed state. We're going to have this pin so it's able to rotate. And then this guy is where we're going to apply the force if you're looking at it in 1, 2, and 3, right? So fixed, pinned, and constraint, or sorry, loaded. So we're going to go ahead and do that. I'm going to add a fixed constraint to this guy right here. We're going to add that to that whole face. If you hit OK, you can select more in the same, I guess, command box. If you hit apply, it's just going to apply it and close this box out completely. So if you wanted to add multiple fixed constraints, for example, you can either select multiple faces at once, or you can hit one face, hit OK. Maybe you want to look elsewhere. Maybe you need to rotate the model around a little bit. Click again, OK, so on and so forth. So I'm just going to apply and close this guy out. And like I said, I'm going to apply a pin constraint as well to this center guy right here. So as you can see, there's these glyphs, and they don't get bigger because that's how Inventor creates them. But as you can see, it gives you the ability to rotate, right? Pretty much the same exact button, the ribbon, right, is shown as a glyph here. Same thing with the fixed. So I'm going to go ahead and OK that. It's going to apply that pin constraint there. moving left to right. Let's continue. We're going to go ahead and look at force. So we're going to apply a force to this hole here in the downward direction, probably perpendicular, let's say, to this line right here, this edge. So let's go ahead and apply a force to this hole. And I've selected the faces. Let's go ahead and automatically it selects a direction in the negative y. That's just where it did. But if I want to change that, right, to another face or respective to another face, I can start selecting some of these other options. This will obviously flip-flop the direction, and then this will let me select the face relative to where the force is going. So I'm going to go ahead and rotate this guy down. I feel like I'm on a cooking show. All right, cool. So I'm going to select this face, and as you can see, the arrow changes now perpendicular to this edge right here. So I'm going to go ahead and change the direction. Obviously, we're not pulling this thing up. We're pulling it down. Doesn't really matter. But in this case example, we're going to go ahead and reverse the direction. So it is down. And faces, do we apply this properly? That guy. Okay, we're good. And obviously, we're going to need to select a magnitude. And this is where it gets a little interesting. The only criteria to create the shape is not actually the amount of force you're applying. It's actually the amount of material you want to take away, whether that's mass or whether that's volume, or you have a target volume, for example, or target mass at the end. That's the only thing that really matters. So you just want to make sure that the force is in the right direction. If you're not sure about the magnitude of the actual force going on here, you don't need to really worry about it. You just need to make sure it's in the right direction and has a magnitude that's positive or negative. So you want to just make sure this vector is correct, not necessarily the size of the vector. So I'm just going to go ahead and let's make this 500 newtons, just because. We're going to go ahead and hit OK, and it applied that force. So as you can see, this arrow denotes that that's there. I can always go ahead and jump into here and right-click any of these to either edit them, suppress them, change the visibility of these if I really wanted to as well, and I can delete them in here as well. So maybe you want to play around with a couple of different loading options, maybe a couple of different constraint options depending on what kind of shape you're building. So just a couple of options there, much like the rest of Inventor, right? Right-click menus give you everything. So we've applied the loads, right? We're only going to apply a force load. You can apply pressure, bearing, moments, and gravity, right? If you really wanted to. I don't really see a huge difference when I'm applying gravity to the entire model. Essentially, you just select what direction it goes in and applies it. So next, right, we're going to create that criteria to be able to select, hey, what areas do I want to keep in the shape and how much mass or maybe material do I want to have at the end? So let's go ahead and take a look at that. Let's go ahead and preserve a couple of regions here. So there's a few locations here that we want to preserve. Generally, it's going to be important things like mounting points, for example. So let me go ahead and just get this in frame here. The only things that really matter here in this design criteria is this connects in 3 places, right? It's going to be this top left, the center, and then the top right. And we're going to need to preserve those holes because, say, for example, bolts go through those. We need to maintain the shape and the size of those holes. We can't really, change those. So we're going to go ahead and preserve those regions. And there's 2 ways to preserve regions. The first way is to create a bounding box where it pretty much doesn't get rid of anything in that volume. And the second one is to create a cylinder. Boxes are useful for other things, for holes generally, which is what you're preserving a lot of the time when you're creating these simulations. You're going to be using that bounding cylinder. So I'm going to go ahead and create some of these preserved regions. So I'm going to go ahead and just select that whole face, right, within the hole. I'm going to go ahead and select that guy out. As you can see, it created a green circle, right? And that's going to be my volume that I'm preserving. Well, right now it's showing that I'm preserving the hole. There's actually no material there, so it really is probably not a great idea. So you're going to want to go ahead and expand this, right? You're going to increase the size so that it encompasses area around this hole so that you're maintaining that material. Make sense? So let's go ahead and change this. And you can pull on any of these glyphs here to make that larger. So I'm just going to make it approximately the size of shape. As you can see there, I'm going to go ahead and apply. And there's more options too, right? If you want to go ahead and denote these by location and by, say, radius and length, you can do that as well. So what I'm going to do is I'm going to select another location. And I'm going to go ahead and select the second hole. Do the same thing. apply that. And obviously you can change the orientation of the cylinder if you want, right? If it's based on the z-axis, which this one is, or the faces of the cylinder are as opposed to the cylindrical side. And then lastly, we're going to do this guy right here. And let's expand this a little bit so it encompasses the whole thing. And we're going to go ahead and OK that. So now if we go back to our home view, or if you double click the center mouse button, that's something I use all the time. It'll bring you back to that home view. You're going to see these 3 green cylinders. And what those mean is those are the areas it's going to preserve. Similarly, we've got some more information here in terms of the criteria. So let's go ahead and take a look at symmetry planes. And it is as it sounds like, right? So you want to create a plane where this creates a symmetrical shape on both sides. In this case, the best case scenario for this guy, probably not creating a symmetry plane straight down the middle in this direction, right? Probably don't want that. It actually probably won't create the part for you. We're going to want to create a symmetry plane somewhere on the midplane of the part here in this direction, right? We want it to be the same on the left side of the center line, the right side of the center line. So let's go ahead and create that symmetry plane. It's going to give us a couple of active planes already, as you can see, and it's going to guess which one we probably want to use. In this case, yeah, we're certainly going to want to be using this red highlighted plane, which is selected already. You can select multiple planes if you want multiple planes of symmetry, for example. Maybe you want your part to be symmetrical in all directions. Sure, why not? So I'm just going to go ahead and select this plane. You can move the box around. You can change the center of mass. You can place it at the center of mass, so on and so forth. I'm just going to go ahead and select OK. There's some other options as well. You can name it something else. I'm just going to hit OK. Generally, the name symmetry plane makes sense. All right, and let's go ahead and keep going. So we've applied loads. We've done some preserved regions. We've applied these symmetry planes. Next is the shape generator settings. And this is where we're going to actually add that criteria to decide, well, how much of this do I really want to keep? This is probably the most important box in this whole tutorial here, AVA. So let's go ahead and take a look at what's going on here. So in regards to the objective, it's pretty much stuck at maximum stiffness for this particular simulation. It gives us the original mass, which is 171 pounds mass. And that's going to be that information from the part file itself, right? If I applied a generic material to it, for example, it's going to attempt to assign one right in that second assign button on the ribbon. And so we're using steel in this case. It's going to be 171 pounds mass. There's 2 options for mass targets. The first one being a reduce percentage. So do I want to reduce my weight by 30%, 40%, 50%? Maybe I want to get to a certain mass. Maybe there's a particular criteria where my entire assembly can only be so heavy, or this part can only be so heavy for shipping purposes, right? I know the difference between 50 and 51 pounds in shipping could be huge, right? You could shoot a completely different, per se, bracket in terms of shipping weight. So maybe you want to go ahead and lower this mass to be able to get under that particular threshold. In this case, I'm going to reduce the original mass. So just keep an eye out. I generally don't start with anything more than 50%. So we're going to go ahead and start at 50% for this guy. And then you've got some minimum member sizes as well. We're going to go ahead and select that off for now. And then mesh resolution. This is really important. And it's the same for all other simulations too. The coarser your mesh, right, the less elements they're going to be, the less nodes they're going to be, and the easier it is for your computer to calculate all of this. It'll probably, depending on how coarse or how fine it is, it's probably going to be less refined in terms of your actual results. And so generally what I like to do is I like to stick around the middle, around value of 3 for regards to the mesh, run a simulation. And if I'm getting something that is expected, right, if I'm taking material out in ways that make sense based on where I'm loading it, then I start going into finer and finer mesh until I get it refined enough where I get, my finished shape. So I'm going to go ahead and do this for the case, or for the sake of this simulation. And I'm going to go ahead and hit OK. We're not ready to generate the shape yet. There is the mesh view, and this is really important if you want to see, right, kind of what all of this looks like when it's meshed out. So I'm going to go ahead and hit mesh view. It's going to compute this mesh, and as you can see, there's a couple of elements through here. It's not super refined, as you see the mesh. The nodes and the elements, or sorry, the elements aren't that big, and there aren't that many nodes. So we've got about 1,200 elements in this guy. For the sake of time in this presentation, we're just going to run it like this. Obviously, you're going to want to keep refining this and getting them smaller and smaller. All right. There's some more options for mesh settings as well. This is pretty much the same as the mesh settings in regular Inventor simulation, Nashua and InCAD. You're going to want to be using the same methodology when you're looking at meshes. The smaller it is, the longer it's going to take. So average element size, it's going to be 0.03, and that's as a fraction of the bounding box length, which is this guy right here. Minimum element size, grading factor, and maximum turn angle for the elements as well. And I think right here we're using TETs for everything. Yeah, so let's go ahead and exit out of that. And the next thing to do is generate the shape. So let's go ahead and click that. It's going to generate a shape for us. And you can see if I hover over anything in the ribbon, it's going to show me what the button does, which is cool. Oh, my computer unplugged. Let me go plug that in real quick before we die. All right, cool. Didn't notice that coming up. It's a good thing I caught that. All right, cool. Let's go ahead and generate this shape. So it's going to say model shape generator example 2. That's my part name, my IPT. Do one study and one configuration, and I'm going to run this guy. So it's going to start computing the results. It's going to take some time to do so. This one, it shouldn't be too lengthy. I've made the mesh 3 in terms of fineness. But while this is running, I'm going to go ahead and answer a couple of questions. See, it was pretty quick. Let's go ahead and answer a couple of questions. Is there a way to make the force in the center of the hole rather than the edge? So yeah, certainly. So I added the force not to the edge, but to the entire face. If you want to apply the force to a particular edge at the center of the circle, go ahead and do a split face. If you do a split face and you add an edge there, like a hard edge here at this point in the circle, you can apply the force to the edge. So for this example, I didn't do a split face. If you want to do that, feel free to do so. So as you can see, we get our final shape here. We're working our symmetry plane as well. And as you can see, we've got our final shape, right? So it's going to take a bunch of material away from here, a bunch of material away from here based on where I've loaded this. And the more and more you refine this, right, as you change the shape generator settings to be more coarse or to reduce original material by so-and-so, you're going to get more refined results. And as you keep going closer to refine, right, I got down to like 0.5. It took a couple of minutes to run it. You start getting different shapes. For example, you're going to get, let's just go ahead and take visibility on this and change this to wireframe. You're going to start to get mesh like this. Sorry, it's yellow. But as you start refining it, you're going to get something like this for this particular example, right? So the more and more you bring this mesh size down, the more and more information you're going to be able to get in terms of how to get rid of it. So how do I go ahead and start changing? How do I get this information to my model itself? Well, that's easy. Let's go ahead and jump back into our simulation that we're working on. We're going to go ahead and promote that particular shape. And so what that does is it's going to promote the conceptual shape into a part file. Let's go ahead and do that. I can promote it to a current part file, which is this one that's open right now, or I can do it to an STL file, right? So I have my full base part file here. I'm going to go ahead and promote the shape to that. Hit OK. And as you can see, it promotes my shape to the original part file that I started with. Essentially, it's created as this shape here in the browser. They tell you a couple of recommended steps. In 2019, they changed it so that it automatically puts the part into wireframe. And that's really important because you want to be able to see this mesh. In this case, yeah, we can totally see the mesh is created in wireframe. And let's go ahead and work with it so we can go ahead and get rid of a lot of that material from our base part. It doesn't create the part for us. It gives us a mesh as a reference to start deleting information from our part. So let's go ahead and modify our guy. I know this isn't super refined, but let's go ahead and use it anyways. All right, so what we're going to do, we're going to go ahead and start sketching. We're going to go ahead and sketch on this region right here, on this face. And let's go ahead and project some geometry. I think this is the easiest way to do it. This is how I do it. So I'm going to go ahead and just select the entire outer edge of this guy. And then these circles as well. And then let's start using some of this stuff. So I'm going to create a circle. Maybe I want to start sketching to here. I'll sketch to, say, here. here. I know you really can't see the sketch. I can because it's a little faint, but let's continue with all of this. So if I zoom in a little bit, I can select this, maybe go to here. I can select this. And you just want to pretty much trace around this guy. And that's what I'm doing. So let me go ahead and finish that guy. Hopefully I got all of the regions that I wanted to get rid of. Let me go ahead and change the visibility of this. Looks like I didn't close this off, did I? Oh, it looks like it's closed. All right, cool. So you can see I've got a general sketch here of how I built this. What do you do now, right? We have this thing in wireframe. Let's go ahead and change it right now. The view tab to, let's just shade it with edges. You can kind of see what we've got going on here. And let's start extruding this. So I use the E button to extrude. It looks like this is not closed. So let me go ahead and fix that. So I can get rid of this region for sure, but we'll go ahead and edit this sketch so we can get rid of that. And we're going to do a both directions, and we're going to do a through all. It's going to be an extrude cut. And then let's go ahead and edit the sketch so that we can get this part as well. And then there's a question in here: can you project the geometry from the wireframe itself? Certainly, you can project you can project the geometry from the wireframe, but you cannot project geometry from the mesh. So that's what I was doing this whole time, projecting geometry from the wireframe of the original part file configuration. And so that's how that was working. Let me just go ahead and just create a line from here to here. Sure. That should work. All right. Let's go ahead and edit this extrusion. If you also wanted to, another tip for people who are working in Inventor, just a quick modeling tip. If you wanted to use that sketch again for something, go ahead and right-click Share Sketch, and that will be able to use the sketch multiple times for different operations. So we'll just do that. Still not closed. Okay. What do we got going on here? This should be okay. Well, we'll see what's going on. I'm just going to make a simpler box. For the sake of this presentation, we're just going to use this. Extrude. Whoops. Went too quickly. That feature. Extrude cut, both directions and through all. General modeling. We'll just refine the shape like this for now. Essentially, you get the idea of what's going to be happening, how this is going to work. If you refine it more and more, you start getting shapes similar to this right here. And what I'll do is, for the rest of this example, I'm just going to show everything off of this because this is already completed. Shade it with edges, and let me go ahead and turn this guy off. Visibility on this. Okay, cool. So this is the same model after I went to, I think, 0.5 in regards to the mesh fineness. I created this model based on that, and then I added a bunch of fillets to it just so it looks a little bit better. But let's go ahead and take a look. If you remember, there is one key number at the beginning of this, 171 pounds mass. What do we have now? Right-click, Eye Properties. Physical properties, and let's go ahead and update. Well, we've already done. We're at 77 pound mass, right? So we've cut that in factor of more than half, probably like 55% or so. Keep note though, that just because I put 500 newtons as the criteria for the actual simulation, it does not mean this thing's going to hold 500 newtons of force. Very well can, probably, maybe, we'll see. But you're going to want to validate that using a real static stress simulation. All it does in the shape generator is take the direction of the force and where you're applying it, not necessarily if it'll break in that direction. So you could have had 1 Newton or you could have had 9 million Newtons. It'll give you the exact same thing. So make sure that you validate all of your designs after you use shape generator. That's why I emphasize use this early in the process. So let's continue. we've got this shape. I can go ahead and the next step, probably go ahead and take this into a simulation. I'm not going to do that right now, but if you do take it into a simulation, you can use a lot of the same setup you did before, right, with those constraints. I'm going to go ahead and pin it here, constrain it here, and apply the load here. And for those people who asked if I could apply the load to a particular point in this circle, you totally can. Go ahead and split this face. You're going to create an edge down here where I'm highlighting. I can sketch on that if I wanted to, but right here, create that edge, and then apply the load to the edge. Do not apply the load to the face. And then you get that, that load at that particular location. So emphasize again, one more time. Make sure you retest this part after you're done for actual real life performance, not shape generating performance. So let's take a look at the two parts side by side. I'm going to go ahead and, this is another example that I could have gone through, but we're going to go ahead and show these side by side. And as you can see, the parts are relatively the same. This one is, let's go ahead and go to home direction on both, right? If we bring this up, oh, sorry. If we bring the end of part up, here's the original, here's the finished product. Start using this with your own designs, right? So bring them in, see how much material you can get rid of. Especially with a lot of things that don't bear a lot of weight, you can use this for a lot of visual, added visuals in regards to your particular products. This particular linkage bracket here is a little bit boring, right? If it's not load bearing in your particular assembly, maybe you want to get it look super cool and futuristic. Maybe you start using Shape Generator for stuff like this as well. So as you can see here, the important criteria, like I'm going to go ahead and go again, is we'll just go back in that sim. The important criteria is going to be how much mass you want to have at the end. So let's go ahead and jump back into that environment and just reiterate what we learned here. Left to right, work from left to right. The important things here are make sure you apply your constraints and loads the same way you would do any other simulation. You want to be able to preserve those regions you want to keep. Right? Obviously, there's some areas of note that you want to keep. As you can see here in this particular example, right, they want to keep the face where they're applying the load to, which is that guy at the top there, and then the two mounting holes at the bottom. Makes total sense. Create a similar symmetry plane if you need to. And then in the shape generator settings, create your mass targets. Don't get too crazy. If you did like 80% or something, you're probably going to get a shape. You'll get a shape. Probably won't get one that will probably hold the load. It's just trying to remove as much material as possible until it gets to that point. You'll probably get something a little broken if you go over 50, 60%. And last but not least, the mesh resolution, right? The coarser it is, the less taxing it is on your computer, the more coarse it is, or the more fine it is, the longer it will take, but the more refined your results will be, right? You get, let's see, let's go ahead and finish the, you're going to get this guy versus this guy. Let me change this all to wireframe. And this guy will do this too. And wireframe. So you get this versus this, right? When you start refining your mesh, and it gets, it starts being a little more trust-like, right? The more and more you go. So make sure you get to a point where you start getting stuff that looks like what you need. So with that, that's pretty much how it goes through, how you go through and start using some of the shape generator tools. Let's go ahead and recap in the PowerPoint. So we got our finished products here on the left. Let's go ahead and recap. Use it early in the design process to get a solid base for your model. You're not going to use this as the completely finished model. You just want to get an idea of what areas you probably don't need material in, but definitely retest all of this to make sure it works. Mesh, don't start small because you're going to waste a ton of time going through a couple of initial iterations. Maybe you didn't load it correctly, or maybe you didn't constrain it correctly. Starting out with a coarse mesh helps a lot in the process. To understand, hey, I'm getting the results that I think I'm probably should be getting based on the loading. I'm in the right direction. Let me go ahead and start refining this from there. So don't skip steps, start small. It's pretty bad. I had a simulation running on my computer for 30 minutes that just blew up because I decided I wanted to start at 0.8 instead of 3. So don't do that. Use the mass reduction tool in regards to percentage to go ahead and control that shape, or a mass target, right? If you wanted to get to 50 pounds per se, 49 pounds. Last but not least, use the Inventor simulation or Nastran in CAD, which is included in the collection for those of you who do have collections, to go ahead and validate the shape generator design after you're done creating the model. If you also have Fusion 360, go ahead and try some of this generative design process in Fusion 360 as well. They use a similar, a little bit different engine. If you want to try both, feel free to do so. It's definitely available to those of you who do have suites and collections. I'm going to go ahead and jump into questions. So those of you who do have some questions, definitely stay tuned. If you have any, go ahead and start asking them. But first, I want to go over one quick promotion. So there is a promotion going on right now. You can save up to 35% on particular Autodesk software upgrades. If you need more information, go ahead and reply to any emails that I've sent you or anyone here at KETIV has sent you talking about the promotion, or give us a call at that number below. So it's quick. Then you guys know there is an opportunity to save some money. Might as well do so. All right, let's go ahead and take a look at some questions. All right. Is the symmetry plane step required? So no, it's not required, right? You don't have to add a symmetry plane if you don't need it. In addition, you can add multiple symmetry planes if you want. Obviously, you can have 2 symmetry planes that are parallel to each other. That doesn't work. So keep note of that. You can have symmetry planes that are in perpendicular directions. That makes sense. Can you project points from the wireframe? Yes, I kind of went over that a little bit. You can project points from the wireframe, but not the mesh. So this is the mesh. The wireframe is the original part file, and I can project all of these like outside components if I really wanted to. Let's see here. Retest the part. That's a definite yes. And how do you get to the detailed mesh settings? So Ben, if you could, I guess, elaborate a little bit on what you mean by that, but I'll jump into the mesh settings so we can see what they look like. Environments. All right. So the mesh settings, the advanced mesh settings are right here. So if you go into this mesh ribbon box, there is the mesh view, which turns on the view of the mesh. And then the mesh settings, which you can go ahead and mess with these if you really want to. It creates these element sizes and such based on this criteria. So this criteria controls the base information for this. But if you want to change it a little bit, you can do that. In regards to doing a shape generator model, you cannot do localized meshes. Say, for example, you wanted the mesh to be finer around these circles. You can't do that in shape generator. So just keep that in mind. All right. Is this in Nastran in CAD? So no, this is not in Nastran in CAD. Anyone who has Inventor Professional will have this starting in 2018, obviously. Like I said, it's in the Simulations tab. So if you go into Environments, Stress Analysis, it lives within there. Nastran in CAD is going to give you a completely different ribbon if you go ahead and open it. It's going to be a completely different environment. Same thing in Fusion. It's not using the Nastran in CAD functionality to do so. Let's go ahead and keep taking a look. All right. It looks like that's just about it for questions. I'll give everybody about 30 more seconds to answer some questions, but I'm going to go ahead and make a couple of announcements. So next week's AVA is all about 5-axis CAM in Autodesk HSM, which is the CAM tool built directly into Inventor, which is this guy right here. Alex Alvarez, one of our simulation expert, or one of our CAM experts in-house, he knows simulation as well, actually, by the way, is going to be going over some of the benefits of using multi-axis simultaneous milling, as opposed to doing maybe two or three different steps when you're using, say, something like 3-axis, for example. Let's see. Does preserving regions cause more processor work? By preserving multiple regions, will the simulations take longer or shorter? It's just a criteria to be able to keep. I haven't really tested whether or not it takes longer or shorter. Usually, when you preserve regions, you have to preserve those particular regions because they're either mounting points or loading points. So I haven't really played with turning them on or off. I have a feeling if I did turn this preserve region off, I'd run into some issues, probably because I have a pin constraint there. So just make sure you're cognizant about where you're preserving these regions, so on and so forth. I've tried new generative design. All right. Do you think it'll be implemented in Inventor 2 as Fusion in regards to the new generative design? I'm not sure where Autodesk stands on creating some of the new generative design stuff in here, as well as Fusion 360. Definitely keep an eye out. If it does happen, you'll hear from us first, or not first. You'll hear from us pretty much as soon as it happens. Once Autodesk makes an announcement that they add something, usually we know about it, and we can go ahead and make that known. So if that's something you're really looking into, Mateo, definitely let me know, and I can see if I can get some insight onto maybe some future plans for some of the generative design improvements and stuff that Autodesk is putting out. How do you go straight to an iPart after the simulation? Or not iPart, IPT. So let me go ahead and do that. So I am in the shape generator location, right? Right now, if I go to my analysis, once I create this shape, I promote the shape to my part file or to a new step file, for example, right? Because it is a mesh or an STL file, sorry. So I can either put the mesh as a brand new STL file that I can put here or wherever, or I can go ahead and promote that shape into my part file itself. If you promote the shape to the part file itself, it closes out the simulation and goes directly into that environment. I have the part file open, so I'm definitely not going into an IPT. I'm already in the IPT. If I really wanted to start 3D modeling, I could. Generally don't want to do that while you have the analysis open. It's probably not a great idea. But if you just finish the analysis, you pretty much go straight into the 3D model tab, right? I never close the part file. I never open another program. I think that's really important that all of this is incorporated inside of Inventor, much like everything that Autodesk is doing, right? With the HSM, with the InCAD, with the nesting, it's all in Inventor. I haven't opened a single other CAD tool or simulation package to be able to do all of this stuff. And then a quick question from Reza. What is the actual safety factor value of this? You would have to run the simulation to do so. So like I said, after you create the shape generated shape, you're going to want to go ahead and take this into maybe a static stress simulation. And I'm going to create a study, static, and then I'm going to go ahead and do the same thing. I'm going to apply the material, I'm going to apply the loads and the constraints, and then I'm going to simulate. And then I'm going to be able to find the safety factor that way. So if you want to know what the safety factor is of the parts, it really depends on how you build it and the kind of regions you cut out. As you can see here, I cut a little bit more than the mesh had just to make it look a little bit better. So obviously you're going to want to simulate that afterwards, make sure it actually holds the load that you're looking at. Like I said, the load really doesn't matter, just the direction and location of where it is for the shape generator stuff. All right. I think that's just about it for questions. Again, I'd like to thank everybody for joining us today for Autodesk Virtual Academy. Hope to see you again next week, going over some of the 5-axis cam in Autodesk Inventor HSM. And I think that's just about it. We'll see you all later. And if you have any questions, feel free to shoot me an email. You have all my email. You have my email address from all of the emails that I send you for these announcements. Feel free to reach out to me. I'm more than happy to answer any questions, hop on any quick phone calls, whether it's about Shape Generator or anything else, right? If you do have any questions, I'll go ahead and take care of it or find someone who knows the answer for you. So again, I'd like to thank you all for being here today. Thanks everybody who's been a part of the AVA team on the back end. You guys make this job a lot easier for me, and we'll talk to you all soon. Thanks. Have a great day.